The simplest Riemann surface is just the complex plane itself. Probably the next simplest Riemann surface is called the extended complex plane, which is actually also known as the Riemann Sphere. Now the Riemann Sphere, what we do is this. Each point on the Riemann Sphere is a sphere of radius 1. Each point on the Riemann Sphere represents a point on the complex plane. The mapping works as follows, that if we take any point on the sphere, we draw a line from the North Pole to that point on the sphere, and then see where that point, that line, then touches the complex plane. And that complex number corresponds to a point on the Riemann sphere. So we arrange things, well, okay, people define the Riemann sphere in different ways. I'm going to define it so that the equator of the sphere actually coincides with the line mod z equals 1 in the complex plane itself. Some people put the sphere sitting on the top of the complex plane. I think this is a nicer way of doing it. So it basically means that any point outside the unit circle gets mapped to the northern hemisphere, and any point inside the unit circle will get mapped to a point in the southern hemisphere. Okay, so that means that the origin gets mapped to the South Pole. But then the question is, what happens to the North Pole? What point does the North Pole correspond to? Well, you see, in the limit, as we get points which are further and further away, they get mapped closer and closer to the North Pole. So in fact, the North Pole represents what's called the point at infinity. And this is a very useful concept because it basically means that we can define what's sometimes called the extended complex plane, which is written C infinity, which is the complex plane, but plus union what's called the point at infinity. We think of infinity as just a single point. So that's plus infinity, minus infinity, I times infinity, minus I times infinity. In fact, e to the I theta times infinity, where theta can be anything, corresponds to a single point, just this point here, the North Pole is infinity. Thinking of infinity as a single point rather than plus or minus infinity as we normally do is actually a very useful, simplifying concept. The reason for this is that we can now say that 1 over 0 is equal to infinity. Before we couldn't do that because we never knew whether 1 over 0 was equal to minus infinity or plus infinity or I infinity and so on. Now we think of there being only one infinity. And with the extended complex plane, we can regard infinity just as another point in our space.